everyone. Hello everyone, welcome to my YouTube channel. Today we are going to learn about what is total internal reflection. Without wasting any time, let's start our video. Let's go. So now let's look at these pictures. By observing these pictures, we can see the mirage is occur on the road, in which we can see some water on the road, although the road was actually dry. So, what is the relationship between this phenomenon and our learning outcomes today, which is to learn about total internal reflection? Without wasting any time, let's proceed to next example. Now, you are given 3 seconds to observe these two pictures. Okay, time's up. So, what we can observe in these two pictures are actually these two pictures, we can see the reflection occur in the surface of the water. So, is this related to total internal reflection too? Let's see another examples. Why we can't observe any reflection in these pictures? Is there got any problem in these pictures? And what's the difference between these pictures and the example we see before? So, to discover this kind of problem, let's look at the definition of total internal reflection. So, what is total internal reflection? Total internal reflection is the phenomenon which occurs when the light rays travel from a more optically denser medium to a less optically denser medium, as the angle of incidence is greater than the critical angle. So does this related to the situation just now? Let's see the definition of critical angle so we can configure out why the total internal reflection doesn't occur in the last example. What is critical angle? Critical angle is actually the angle of the incidence ray when the angle of reflection ray is equal to 90 degrees. So, does this critical angle so important to total internal reflection? Let's see some situation. Okay, by observing this situation, as what we see, when the light ray travels from denser medium to less dense medium and the angle of incidence ray is less than critical angle, the refraction will occur. Now, in this situation, the angle of incidence is greater than the critical angle. And what we can observe is actually the total internal reflection does occur in the image. So, does this related to our situation just now? Let's see the term and condition that the total internal reflection needed. So, the two term and condition of total internal reflection is actually, first, the light travel from more optical dense medium to less optical dense medium. And second, the angle of the incidence ray should be greater than the critical angle. The total internal reflection only occurs when these two conditions is achieved. And this does explain why the last situation just now, the total internal reflection couldn't occur. So, what is the formula that we can learn in these topics and how to calculate the critical angle for certain optical medium? Let's see now. Before this, we have learned Snell's law, which the optical density n is equal to sine incidence ray divided by sine theta of refraction ray. As what we know, critical angle is the angle of incidence when the angle of refraction is 90 degrees. So, in this situation, we can substitute the 90 degree into the sine theta incidence, and the refraction angle will become C. Since sin 90 degree will become 1, and the refractive index is actually equal to 1 over sine critical angle. Now, let's look at the application of the total internal reflection in our daily life. Well, actually, optical fiber is one of the applications in our daily life which use the concept of total internal refraction. Now, let's see how does it works. Well, optical fiber was actually designed to have an inner core which having a greater index of refraction than the outer surface of optical fiber. So, when the incidence ray, we call it as signal, was emitted into the optical fiber, total internal refraction will occur because the angle of incidence ray is greater than critical angle. Let's think about it. Why we use total internal reflection instead of using reflection in this situation? And what's the difference between reflection and total internal reflection? In total internal reflection, the energy loss is equal to 0. And that is why we use this concept in optical fiber. As the conclusion of our videos, we have learned what is total internal reflection and what is critical angle. We also learned about formula that we use in the situation that to calculate the critical angle. And we also learned about the phenomenon and the application in our daily life related to total internal reflection. That's all for today. Thank you everyone.